Given 2 to the power of x multiplied by 4 to the power of y equals 1 over 2 root 2, express y as a function of x. Okay, so in this question, you can see that we're dealing with indices and we've got 2 with different bases, and what we should immediately do is convert one of the numbers to the same base as the other number. In this case, we know that 4 can be written as 2 to the power of 2. So we can rewrite this as 2 to the power of 2y times by 2 to the power of x equals 1 over 2 root 2. And then obviously we know that when we multiply two numbers with the same base, the indices add each other. So you do 2 to the power of x plus 2y equals 1 over 2 root 2. But obviously we can't solve this yet because this also isn't in base 2. We can write 2 to the power of, or 2 root 2, as 2 to the power of 3 over 2. This is because obviously this is 2 to the power of half, and this is 2 to the power of 2 over 2, and then you times them, you add the powers, you get this. And then we can just write it as 2 to the power of minus 3 over 2, the minus signifying it is 1 over 2 to the power of 3 over 2. And then we obviously know that if this is 2 and this is 2, and this will equal this, we can just set them equal to each other. So we can do x plus 2y equals minus 3 over 2. And then we can just write 2y equals minus 3 over 2 minus x. And then we just divide by 2 on each side. And that gives us y as a function of x. So we've got an expression for y. Okay, the speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time when it was left on the ground. The results are given in the table below with the time in seconds and the speed in meters per second. Using all this information, estimate the length of the runway used by the jet to take off. Okay, so for this question, we're going to use this formula. This is for the trapezium rule. The graph isn't really given, but you can sort of assume that it will be like a trapezium. And you just basically calculate like that. Okay, so we know that our h is going to be 5. That's given here in the equation. Or question, 5 seconds. So you do 5 over 2h, and y0 is 2, and the last y is 42. And then you just do all of these times by 2, such as 2y1, 2y2, so on. And then we can just multiply this out, and we get 415 meters. Explain whether your answer to part A is an underestimate or overestimate of the length of the runway used by the jet to take off. So this would be an overestimate because the curve is convex. So basically you just have to use either concave or convex to determine whether it's under or overestimate. You can also say that acceleration is continually increasing. Okay, question 3. Figure 1 shows a sector AOB of a circle with centre O, radius 5 and angle AOB, which equals 40 degrees. This is the attempt of a student to find the area of the sector, and we need to explain the error. So the first thing that they've done is they've obviously used the correct formula for area of the sector, which is half r squared theta. And then they've used half and then the radius as 5, which is correct, and the theta value as 40. Now in the question they obviously say that AOB, the angle, is 40 degrees. And we know that when we try and work out the area, this theta value must be in radians. And that even goes for arc length, like this theta value should always be in radians. So yeah, that's all you need to say, it's only 1 mark. So yeah, theta is measured in radians. Or you can say that student did not convert 40 degrees to radians. And obviously it's going to ask us to write out the correct solution. So we know that r equals 5, that part was correct. And we know that 40 is our degrees, but we need to calculate it into radians. So our formula for radians is degrees multiplied by pi over 180. And that just gives you 40 times pi over 180, which is just 40 pi over 180. You can obviously simplify it and you'll just get 2 pi over 9. And now we can put that back into our equation. We can do half r squared theta, so half 5 squared times by 2 pi over 9. And you get 25 over 2 times by 2 pi over 9, and that gives you 50 pi over 18, which you can also simplify to 25 pi over 9 centimeters squared. Okay, the curve C1 with parametric equations x equals 10 cos t and y equals 4 root t, 2 sine t, meets the circle C2 with the equation x squared plus y squared equals 66 at 4 distinct points as shown in figure 2. Given that one of these points, S, lies in the fourth quadrant, find the Cartesian coordinates of S. So S is in the fourth quadrant. This is 1, 2, 3, 4, I'm pretty sure. And when a coordinate is in the fourth quadrant, you can also kind of see here that it's going to be a positive x coordinate and a negative y coordinate. So that is what we're looking for. So we might get two values that, for example, like 3 and -3 as the y value, and obviously pick -3 in that scenario because it needs to be negative y and a positive x. Okay, so let's proceed. It's saying that we need to find one of the points where these two curves meet, and we've got this equation and this equation, or these equations. So basically all we need to do is just plug these into this equation. So we've got x squared plus y squared equals 66. We know x is 10. We know that x is 10 cos t, and y is 4 root 2 sine t. And you can just expand it like this. And we can also rewrite it in terms of cos squared t. We know that our identity for sine squared t is 1 minus cos squared t. You can just expand it all out and you get this. And eventually you get cos squared t equals half. And then we can obviously square root that to get cos t, plus minus square root half. And then we can just work out what t is. We've got 1 over 4 pi and 7 over 4 pi. For a negative value, we get 3 over 4 pi and 5 over 4 pi. Okay, so now we can find x and y coordinates. We already have our t, so we can just sub it into these equations. So when t equals 1 over 4 pi, x equals 10 cos pi over 4, which is another way of saying 1 over 4 pi, and y equals 4 root 2 sine pi over 4, you get x equals 5 root 2, y equals 4. Now immediately we know that, well, is this correct? The x term is positive, the y term is positive, so that gives us somewhere around here, which is obviously not s, so we need to keep going. We can do t equals 7 over 4 pi, and you just do the same thing you did in the last step, and you get x equals 5 root 2, and y equals -4. Okay, let's check. We've got 5 root 2 somewhere here. I'm not actually sure if it's there. Somewhere here, and then we've got y somewhere here. So we can actually say, well, can you say that? So yeah, that can match up with s, because, you know, obviously there's 4 different points. You've got 2 more t values, so they must be somewhere here. So your s coordinates are 5 root 2 and -4. Okay, question 5. Figure 3 shows a sketch of the curve with the equation y equals root x. The points P, x, y lies on the curve. The rectangle shown shaded in figure 3 has a height y and a width, I don't know what that is. What is that? I actually don't know what that is, but no, sorry, I don't know the name of this. Is it delta? I'm not sure, but yeah, this x. Calculate this. So essentially this can just be written as you integrating y, and you have 9 and 4 as your limits, as shown here, and also here. So when we do that, we obviously can rewrite root x as x to the power of half, and then we can increase the power, which gives you 3 over 2, and then divide x by 3 over 2, which is just 2 over 3x to the power of 3 over 2. And you can just put in your limits, 9 and 4, into the x. And if we expand that, we get this, which gives us 18 minus 16 over 3, which is 38 over 4. Okay, question number 6. Figure 4 shows a sketch of the graph y equals g of x, where g of x equals x minus 2 squared plus 1, x is less than or equal to 2, and 4x minus 7, x is greater than 2. Find the value of g 0. Okay, so basically it's saying to use these to find g of g 0. So first we need to find g of 0, and we can put that back into the equation of g. So we're going to use this first equation to work out g of 0, and we just need to put 0 into the x, so we get 0 minus 2 squared plus 1. Obviously inside the bracket it just becomes minus 2, and minus 2 squared is 4, because the minus gets cancelled out, and then you add 1, which gives 5, and then we can put this value of 5 back into this part of the g, so g of g 0 is 4 times 5 minus 7, and that is 13. Okay, find all the values of x for which g of x is greater than 28. Okay, for this question, what we're basically going to do is, let's just draw out y equals 28 on this curve. We're going to do it somewhere here, and we're just going to write 28. And we're going to set each of these equations equal to 28, so the first equation being this one. And you can obviously deduce that as obviously this looks like an x squared curve, and this is just a straight line. And this is just a straight line with a positive gradient, like here. And then we're basically just going to find the point at which g of x, which is here, starts to become greater than 28, so greater than this point. So we're going to find this point and then set whatever is equal to this point is basically greater. So essentially we're just going to do x minus 2 squared plus 1 equals 28. We can do minus 1 both sides, square root it, and you get x minus 2 equals plus minus root 27. And then your x coordinates are 2 plus minus root 27. Now what we need to do is we need to obviously find out which x coordinate we need to talk about, because there's 2. So 2 plus root 27, this is a quadratic graph. So imagine that this was the full graph, because that's what we're basically assuming. The 2 plus root 27 would come somewhere here, and the 2 minus root 27 is obviously negative, so it's going to come somewhere here. So we can say that the point would be, the x-coordinate for this point would be 2 minus root 27, because obviously we'll get 2 values when this will meet it again, so we're just working out this value because that's what's in the question and in the diagram. So yeah, we can say that x is less than 2 minus root 27, which is true. When x becomes less than that, when it goes on this way, it starts to become greater than. Okay, and then for this one, for x minus 7, this is a straight line, and this is the point it meets 28. And for all the values, when it meets 28, the x-coordinate, it gets larger, the y-coordinate gets essentially bigger than 28. So we need to find when 4x minus 7 is greater than 28. So obviously you can just add 7 on both sides, divide it by 4 on both sides, and you get x is greater than 35 over 4. And you can say g of x is greater than 28 when x is less than 2 minus root 27 and x is greater than 35 over 4. Okay, explain why h has an inverse but g does not. H is a 1-to-1 function, whereas g is a many-to-1 function, so you can basically work out the inverse. And now it's saying to work out h inverse x equals minus half. So this is our equation for h, and we can just put minus half into the equation where obviously x is equal to minus half, which gives you 25 over 4 plus 1, which gives 29 over 4. Okay. A small factory makes bars of soap. On any day, the total cost to the factory, pounds y, of making x bars of soap is modelled to be the sum of 2 separate elements, a fixed cost, a cost that is proportional to the number of bars of soap that are made that day. Write down a general equation linking y with x for this model. So general equation, well, it says that this is going to be a cost that is proportional to the number of bars of soap, so we can sort of imagine, let's just draw this out. Okay, so we've got y, which is our cost to the factory, and x, which is our bar of soap. And we're saying that the cost is proportional to the bars of soap, so it could be like this or it could be like that, but either way it's going to be a y equals mx plus c curve, as it's going to be a straight line. Obviously if we had like this, that's not proportional because it's not a straight line, so we'd say that this is just y equals mx plus c. The bars of soap that are sold are for £2 each, and on the day when 800 bars of soap are made and sold, the factory makes a profit of £500. On a day when 300 bars of soap are made and sold, the factory makes a loss of £80. Using the above information, show that y equals 0.84x plus 428. Okay, so each bar equals £2, and we need to work out the cost. And how we're going to work out the cost, which is basically y, we're going to do, well, we've got 800 bars of soap which are made, but it only makes a factory of £500. Well, without the cost, how much could it have made originally? Well, that is 800 times 2. because obviously each one is £2. So that will give you £1,600 or £1,600, but it only makes a profit of 500. So you basically work out 1,600 minus 500, and that gives you a total cost of 1,100. And then we can say y equals 1,100, that is your total cost y. And then x equals 800 in this case. And then for the second case, which is this day here, it says that obviously the cost is going to be 300 times by 2, but then it makes a loss of £80. So it's basically saying that the original cost is this times this plus £80. So 2 times 300 is 600, plus 80 is 680. And for this question, you can, for this day, you can say that your cost is 680 and your bars of soap is 300. Now, obviously, this is a cost and bars of soap curve, or line, should I say. So we need to work out the gradient. So we've got our coordinates here, 800, 1,100, and 300, and 680. So we know that y2 minus y1 over x2 minus x1 is equal to a gradient. So we can do that here. We've got 1,000 minus 680 over 800 minus 300. That gives you this, which can be further simplified into 0.84. And then we use our general, line equation to work out y equals mx plus c, which we said in the original question is the equation we're going to use. So you just do y minus 1,100 equals 0.84 x minus 800, expand that, and you get y equals 0.84x plus 428. With reference to the model, interpret the significance of the value of 0.84 in the equation. Okay, so 0.84 basically signifies that for every added bar of soap, the cost increases by 84p. So yeah, that's the gradient basically. And then it says find the least number of bars of soap that can be made on any given day for the factory to make a profit that day. So our profit equals 2x minus 0.84x plus 428, and that gives you 1.16 minus 428, and you can set these to equal each other, and then you can divide each side by 1.16. I should have done x. And yeah, x equals 369 bars to make a profit. Obviously you need to round this up because you can't have like lesser number than this, because if you do that then it could still give you a lesser profit, but you just round up. Okay, find the value of this. So we can see here that this is a geometric equation or geometric sequence, and we know that this is saying sum to infinity. So sum to infinity equals a over 1 minus r, and we know that our a is just 20 times 1 over 2, and then with our r, which equals 4, over 1 minus half. That's our r value here. And if you expand that, you get 10 over 4, which equals 2.5. Okay, this question is, I don't know why, but this animations didn't really work, but essentially it says show that blah 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 this equals 2. So what we need to do is we basically from n equals 1 sub in that into this question and keep adding it, as this is obviously a sum, all the way until you get 50, but you don't need to do all the steps. So for example, you do n equals 1, so 1 plus 2 equals 3, and then 1 plus 1 equals 2, so 3 over 2, so you do log 5 3 over 2, and then for the next one you do log 5, and then 2 plus 2, which is 4, 2 plus 1, which is 3, 4 over 3, and then you keep going, and then obviously I'm not doing all of it because that's very silly and time consuming, and then we can work it out until the last one, which is 50 over 49. And how do you know that your last value is 50 over 49? Well, in this thing here, basically, you know that your last value of n is 48. So if you put 48 into this, 48 plus 2 equals 50, 48 plus 1 equals 49, and then that is your last value. Okay, and then what do we do next? Well, we can see what we need to do next, but when you add logs to the same base, whatever this is, they obviously multiply by each other, so you get 3 over 2 times 4 over 3, blah blah blah, and this goes all the way on. However, obviously when we're multiplying, we can simplify using 3 and 3, 4 and 4, etc. So I can show you that here, 4, 4, 5, 5. And obviously I haven't done all the values, but you can just assume that 6 will also get cancelled out. You can assume 47 will get cancelled out. You can assume 46 did get cancelled out. 48, 48, 49, 49. But then there's no value for 50. There's also no value for 2. So it's just 1 over 2 times by 50, which gives you 50 over 2. And this will give you log 5 bracket 50 over 2. Can't forget the log 5. And this becomes log 525. And what number do we know to the power 5 to the power of gives 25? That is just 2. So yeah, they both match. A research engineer is testing the effectiveness of the braking system of a car when it is driven in wet conditions. The engineer measures and records the braking distance d meters when the brakes are applied from a speed of v kilometers per hour. Graphs of d against v and log 10d against log 10v were plotted. The results are shown below together with a data point from each graph. Explain how figure 6 would lead the engineer to believe that the braking distance should be modelled by the formula d equals kv to the power of n, where k and n are constants, with k is approximately equal to 0.017. Okay, so that was a really long question, and it's basically asking us to explain how figure 6, which is here, would lead the engineer to believe that the braking distance should be modelled by this formula. So we've got this formula here, and this is obviously our log 10 graph. So what we need to do is we need to obviously multiply each side, or take each side to the base of log 10. And you get log 10d equals log 10k vn, which can also be rewritten as log 10k plus log 10 vn. We know this using our laws of logarithms. When two numbers are multiplied in a logarithm, they can just be taken out and added, vice versa. And yeah, you get log 10k plus log 10v to the power of n. And we also know from our laws of logarithms that if you've got a number to the power of something in a log, the number can be taken to the front of the log, like so. So you get n log 10v. And then we can obviously see that in figure 6, which is what we're trying to prove should be modelled by this formula, is that this is a straight line, so it's modelled by the equation y equals mx plus c. And we need to figure out what each of these are in this equation. So our y would be log 10d. And do any of these have a constant in front of them? N is a constant. So you can say that x is log 10v and your m value is n. And then you can say your c value is log 10k, which is your constant, because obviously n is going to keep multiplying because it's a gradient, but your constant is log 10k. And our y-intercept is going to be a 0 minus 1.77, which is shown here. This is your y-intercept, the part where the equation intercepts the y-axis. And c, your constant in this equation, is also known as your y-intercept. So you can just set these to equal each other. Minus 1.77 equals log 10k. And then you can obviously write 10 to the power of minus 1.77 will equal k. And if we expand that, we get k equals 0.0169, which is approximately equal to 0.017, which is in line with this k value here. Okay, find a complete equation for the model giving your value of n to 3 significant figures. Okay, so now we're going to use figure 5 to help us work it out, because it's telling us, I don't read the spot, but using the information given in figure 5 with k equals 0.017. So we've got this point valued here. It's nicely given us a coordinate, which is 30 and 20. So VD is 30 and 20. Obviously this is V and this is 20, D, which is 20. And D equals KV to the power of N. That was your equation for the model in the last question. And then we can put V and D coordinates here into this equation to work out the value of N. So 20 equals K times 30 to the power of N. K is 0.017, so 0.017 times by 30 to the power of n equals 20. And then you get 30n equals 20 divided by 0.017. And you can take log 10 of both sides to work out the value of n. And you can just divide everything by log 1030. So this divide by log 1030 will give you n. And obviously do this in your calculator and you will get n is approximately equal to 2.08. So then we can rewrite this equation as D equals 0.017 V to the power of 2.08. Sean is driving this car at 60 kilometers per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. It takes him 0.8 seconds to react before applying the brakes. Use your formula to find out if Sean will be able to stop before reaching the puddle. So Sean is driving his car 60 kilometers. Okay, so basically D is 0.017 v to the power of 2.08. That is our formula here. It's telling us to use that formula. And then it says that Sean is driving this car at 60 kilometers per hour when he notices a large puddle. So this is basically after he applies the brakes. So we're going to do v, which is 60, which is our speed, into this equation to work out the distance after applying the brakes. So you get 0.07 times 60 to the power of 2.08, giving you 84.9 meters, and that is after he applies the brakes, so that is that distance. And then to find out the braking distance before he notices, it says it takes him before he applies brakes, it says it takes him 0.8 seconds to react. Okay, so we've got our speed here, which is 60 kilometers, and we need to convert that into seconds as we're using seconds here. And that gives you 60,000 meters, and then you divide this by 3,600 to get seconds, and that gives you 50/3 meters per second, and 0.8 times by this value works out the number of meters, because obviously speed times by time will equal your distance, and we know that this is our speed. And then we're not done yet. Obviously we've got 13.3, which is our distance before applying brakes, and we need to find out if he'll be able to stop before reaching the puddle. He's 100 meters away from the puddle, so we're just going to add these two distances. And that gives you 98.3, which is less than 100, so yes, he does stop in time. Okay, question number 10. Figure 7 shows a sketch of triangle OAB. The point C is such that OC is 2OA. So this is our distance O to A here, and we need to find out what point C is, and that's 2OA. So imagine this is 1OA, and this is obviously 2 times by OA, and that's your C value. And the point M is the midpoint of AB. This is AB here. M is going to be a midpoint. And the straight line through C and M cuts OB at point N. So this line here will cut through OB at point N. Given that OA equals A and OB equals B, find C to M in terms of A and B. Okay, so let's just write this down first. We know that OA is just A, and that's in this direction, and OB in this direction is B. So first let's work out AB. So A to B is just going to be minus A plus B. And then we can work out A to M. A to M is just the midpoint of AB from here, so we can just do minus half A plus half B. And then to work out CM, so that is there to there, or the best logical thing to do would be go from C to A to M, because we know what A to M is. And we know that C to A is A, because obviously OA is A and OC is 2 of OA, so this would also just be A. So you do minus A plus this AM here, and if you expand that out, you get minus 3/2A plus half B equals CM. Show that O to N equals 2 minus 3/2 lambda A plus half lambda B, where lambda is a scale constant. Okay, so we know that ON is O to C plus C to M. That should be a C, sorry. Okay. Yeah, that should be a C. So we obviously know that O to C is 2A, and C to M from the last question is just this. Okay, so let's expand that. We get 2A plus half B lambda minus 3/2A lambda, because obviously it's lambda CM for some distance of CM. And what we're going to do is we're going to move the A's to one side and the B's to one side, like so. And then we can just take the A out of the equation, and you get 2 minus 3/2 lambda A plus half B lambda. And that perfectly matches this O to N equation here. Hence, prove that O to N to B is in the ratio 2 to 1. Okay, so we know that O to N is basically XB, so X is basically a constant, which multiplies by this distance here, which is obviously B. Okay, so we're going to do XB equals 2 minus 3/2 lambda A plus half lambda B, And we know that from the last question, that is our equation for O to n, and we need to work out basically lambda. Okay, so we can see from this equation here that xb is equal to this equation of O to n. So we know that a constant in front of a does not actually match up to anything as there's no a, so this just equals 0. And we know that the b is obviously equal to x, so we say x is equal to half lambda, but we can work that out later. So if we take the a equals 0, we get 2 minus 3 over 2 lambda equals 0. And we can add 3 over 2 lambda on both sides, and we get lambda equals 4 over 3. And to work out x, you can obviously do, as I said, x equals half lambda, and we know that lambda is equal to 4 over 3, so we get x equals 2 over 3. So O to n can be written as 2 over 3b, like so. And then if this entire O to b is equal to b, and this here is equal to 2 over 3b, then n to b, the rest of it is just going to be 1 over 3b, right? Because they both need to add up to b. So you get 2 over 3 to 1 over 3, and you can times everything by 3, and you get the ratio 2 to 1. I don't know what happened there, but figure 8 shows a sketch of the curve C with the equation y equals x to the power of x, where x is greater than 0. Find, by firstly taking logarithms, the x coordinate of the 10 points of C. So, y equals x to the power of x. To find this value of x, we're going to take ln on both sides. You get ln y equals ln x to the power of x, where you obviously bring the x to the front, so you get ln y equals x ln x. And then to find the turning point of an equation, you just find the derivative of that equation and set it to 0. So if we do that here, we get 1 over y multiplied by dy over dx, as we're taking it in terms of x, equals, and then we use the product rule, so u equals x, v equals ln x. U differentiated equals 1, and ln x differentiated is 1 over x, and then we can just use the product rule here. X times by 1 over x plus ln x times by 1 just gives you 1 plus ln x, which is obviously equal to 1 over y times by dy over dx. And then we know that our turning point is equal to when dy over dx equals 0, so you can just set this whole entire thing to 0. We can work out that 0 equals 1 plus ln x, and minus 1 equals ln x. So if we take e to the power of both sides, the ln cancels out, and you get e to the power minus 1 equals x. Okay, the point P, alpha 2, lies on C. Show that 1.5 is less than alpha, which is less than 1.6. So you're basically showing that alpha is a root. So we have our equation y equals x to the power of x, and we've got these coordinates of P here. So we can just put alpha into the x part and 2 into the y part. 2 equals alpha to the power of alpha. And then when alpha equals 1.5, I'm not sure if it's alpha or a, whatever. You obviously put 1.5 into this here. So you get 1.5 to the power of 1.5, which gives you 1.84. And when alpha equals 1.6, you get 1.6 to the power of 1.6, which gives you 2.12. And 1.84 is less than 2, and 2.12 is greater than 2. And obviously this is your point here where the y coordinate is 2. Because C is continuous, this means that this value should lie between these two limits. A possible iteration formula that could be used in an attempt to find alpha is x n plus 1 equals 2xn to the power of 1 minus xn. Using this formula of x1 equals 1.5, find x 4 to 3 decimal places. So our x1 is 1.5 as given in the equation, and to work out x2, you just do x1, which equals n, because obviously x1 plus 1 is 2, and then 2, 1.5 as xn to the power of 1 minus xn, which is 1.5, gives you 1.633. And basically to get x3, you put this 1.633 into the xn, and you get 1.466. And for x4, you do the same, and you get 1.673. Describe the long-term behaviour of xn. So xn essentially oscillates between 1 and 2. Okay, question 12. Prove cos 3 theta over sin theta plus sin 3 theta over cos theta is equal to 2 cot 2 theta. Okay, so this is our equation here, and we're going to multiply this fraction by cos theta on both the numerator and denominator. And we're going to multiply this part by sin theta on the numerator and denominator, and that will give us the same denominator to make things a lot easier. So it gives you something like this: cos theta times by cos 3 theta plus sine 3 theta over cos theta sine theta, like this, and then yeah, like that. And what we can actually spot from this is that it matches up to one of our addition formulas, which is cos A minus B equals cos A cos B plus sine A sine B. Does this reflect this? Yes, it does, because we have cos A cos B plus sine A sine B. So this part, the numerator, equals this. And in this case, our A is 3 theta and our B is theta. And you can rewrite this as cos 3 theta minus theta equals cos 2 theta. And you can write cos 2 theta over cos theta sine theta, like this. And then we can obviously see that this bottom part here matches with the double angle formula of sine, which is sine 2 theta equals 2 sine theta cos theta. And obviously this is not 2 sine theta cos theta, so you can just do half. So half sine 2 theta, and then with the numerator cos 2 theta. And that can simplify into 2 cos 2 theta over sine 2 theta. This gets rid of, and just the 2 gets put here. And then we can use the equation or the formula for cot, which is cot x equals cos x over sine x. Cot x is also equal to 1 over tan x, which is the same as cos x over sine x. So do it whichever way you like, but this is obviously the easiest way for me to remember. So this becomes cot x, and this 2 multiplies by the cot x, and you get this equals 2 cot 2 theta, which is matching this part of the equation, the right hand side. Hence, solve for 90 degrees less than theta less than 180 degrees, the equation that we were given before, equal to 4, giving any solutions to one decimal place. So this is what we got before. We got this part is equal to 2 cot 2 theta, and what is going on? Yeah, and that is equal to 4. And then we can work this out by dividing by 2 on both sides. Cot 2 theta equals 2. And then obviously in our calculator we can't directly work out cot, so we know that another value of cot, like I said earlier, is 1 over tan. So you can do 1 over tan 2 theta equals 2. Multiply by tan on both sides to get rid of the fraction. 2 tan 2 theta equals 1, and then 1 over 2 equals tan 2 theta. And then when we take the inverse of tan with half, this will give you the value of 2 theta rather than theta. So we need to change this range here to make sure we get the right range for the values of 2 theta. So you multiply everything by 2, you get 180 less than 2 theta less than 360. And then tan inverse half will give you the values of 2 theta being 26.565, which is not in range. And then we add 180 with all of our tan values, and the next value you get is 206.565. If we add 180 again, we'll get something like 386 or something, which is way out of the range. So we stop here, and this is our value of 2 theta. And to get theta on its own, we just divide it by 2, and we get 103.2825. And to one decimal place, this is 103.3. A manufacturer produces a storage tank. The tank is modelled in the shape of a hollow circular cylinder closed at one end with a hemispherical shell at the other end, shown in figure 9. The walls of the tank are assumed to have negligible thickness. The cylinder has radius r meters and height h meters, and the hemisphere has radius r meters. The volume of this tank is 6 meters cubed. Show that according to the model, the surface area of the tank in meters squared is given by 12 over r plus 5 over 3 pi r squared. Okay, so what we need to do for questions like this is use the information provided in the question, because that will give us hints on how to do what the question is actually asking. So here in this question, we've got information here. Cylinder has radius r meters and height h meters, and the hemisphere has radius r meters. And here we're even given the volumes for the sphere and the surface area, and we've got the information about the volume. So we know that the volume is 6 meters, so we can maybe set out an equation for the volume of this and equate it to 6 meters to find out some values. So we know that a volume equals pi r squared h for a cylinder, and then the volume of this sphere is 4 over 3 pi r cubes, but obviously we don't need the sphere, we just need half of the sphere. So we're going to do this divided by 2, which is 2 over 3 pi r cubed, and we just add it to the pi r squared h. and we can equal that to 6. Okay, and then what this volume equation has, which the surface area equation doesn't have, is the h. So we might need to work out this value of h in terms of r so that we can substitute it into the surface area equation. This might not make sense now, but if you keep doing it and watching, you'll understand. So to rearrange this, we're going to minus 2 over 3 pi r cubed on both sides. And to work out h, you're just going to divide by pi r squared on both sides as well. That gives you 6 over pi r squared. Obviously, this cancels out and you're left with r, so minus 2 over 3r, which equals h. Now we're going to work out the surface area formula, and that is this here, and I'll just explain it now. So 2 pi r squared, this is your sphere surface area, because obviously it tells us here that the surface area of the sphere is 4 pi r squared, but we only need half the sphere, so we just divide that by 2, so we get 2 pi r squared. And then 2 pi r h is just the formula of the surface area of the cylinder. And then lastly, we need the surface area for this bottom bit here, which is just the area of a circle, which is just pi r squared. And then we can simplify this into 3 pi r squared plus 2 pi r h. Now this is our surface area formula so far, and this is what we need. So what we can see is obviously there's no h, but there's a h here. So what do? We use the value of h from earlier, from the volume question, and we put this into this value of h here. So we use something like this, and as you can see, with the 6, the pi r cancels out, and you're left with 6 over r. So you basically just get something like this, 3 pi r squared plus 12 pi r over pi r squared minus 4 pi r squared over 3. Okay, so to add these, just to make it easier, obviously we know that the pi r square here matches up, but we can't minus them as they're obviously not the same denominator, so you can just multiply by 3 on each side. So 3 over 1 times by 3 on each side gives you 9 over 3. So you get 9 pi r squared over 3 minus 4 pi r squared over 3 plus 12 pi r over pi r squared. And that simplifies into 5 pi r squared over 3 plus 12 pi r over pi r squared. Now we can see that the r here and the r here cancels out, and the pi and pi here cancels out. So you're left with 5 over 3 pi r squared plus 12 over r, which is this equation here. Use calculus to find the radius of the tank for which the surface area is a minimum. Okay, so we know from the last question that our surface area was given as 5 over 3 pi r squared plus 12 over r. Okay, so when it says minimum, that means that we need to find the derivative and then set it to 0. So in this case, we do ds over dr, which is 5 over 3 pi r squared plus 12 r to the power of minus 1. So then when you differentiate this, you get 2 times by 5 over 3, which is 10 over 3 pi r, plus, and then minus 1 times 12, which is minus 12 r to the power of minus 2. And then what we need to do is we need to set this derivative to 0, and then we can just equate these to each other to find r, which is our radius. And we can rewrite this as 12 over r squared equals 10 over pi r. You can multiply r squared on both sides, and you get 12 equals 10 over pi r cubed. And then we can obviously divide each side by 10 over 3, and you get 36 over 10 equals pi r cubed. And then if you divide each side by pi, you get 36 over 10 pi equals r cubed. And if we take the cube root, we get r equals cube root of 36 over 10 pi. And when we do this in your calculator, you will get r equals 1.05. Calculate the minimum surface area of the tank, giving your answer to the nearest integer. So this is our surface area equation, and this is our value of r as we worked out, and all you need to do is just put r into this equation, and that gives you 17.2 meters squared. Use the substitution u equals 4 minus root h to show that this whole thing is equal to this, where k is a constant. So I just could not be asked to say this whole thing. But what we're going to do first is we're going to rearrange this. So we get h to the power of half, because you can just rewrite root h as h half, equals 4 minus u. So just add root h and then minus u on both sides. And then to get h on its own without the power, you can just square it. So you get h equals 4 minus u squared, and then when we expand that, we get h equals 16 minus 8u plus u squared. And now what we can do is we can differentiate this. So we get dh over du equals minus 8, as this u cancels out, plus 2u. And then if we multiply by du on both sides, we get dh equals minus 8 plus 2u du. And now that we know our value of dh, we can put this back into this part of the equation, and you get 2u minus 8 du over 4 minus root h and just integrated. And obviously we know that 4 minus root h is given by u. So you can write that as 2u minus 8 over u du. And that can just be rewritten as 2 as the u's cancel out, minus 8 over u du. And now we just need to integrate this. So we know that this will just become 2u and this will become minus 8 ln u, and then obviously you can't forget your plus c. And then from the question we know u equals 4 minus root h, so we can put that back into this equation like so. And then you just keep expanding it as you go along. You get 8 minus 2 root h minus 8 ln 4 minus root h plus c. And you can just rearrange this to get minus 8 ln bracket 4 minus root h minus 2 root h plus c plus 8. And you can kind of see that it does match up with the equation given in the question. And then the c plus 8 you can just write as k as your constant, like so. And that is it. A team of scientists is studying a species of a slow-growing tree. The rate of change in the height of the tree of the species is modelled by the differential equation dh over dt equals t to the power of 0.25 bracket 4 minus root h all over 20, where h is the height in metres and t is the time, measured in years after the tree is planted. Find, according to the model, the range in heights of the tree in the species. Okay, so first what we want to do is we want to find the value of h. So we can set dh over dt to equal 0. And then that means that this whole thing is going to be equal to 0. And obviously you can say that this occurs when 4 minus root h equals 0, as if this is 0 then everything becomes 0. Add root h on both sides and you get 4 equals root h, and if you square that you get h equals 16. And then we can say that the range of the height is 0 less than equal to h less than 16. 16 is the maximum height. Calculate the time this tree would take to reach a height of 12 metres, giving your answer in 3 significant figures. Okay, so dh over dt equals this part of the equation, and we're going to multiply each side by dt, and you get dh equals this multiplied by dt. And then with some moving around and dividing and moving to the other side, you'll get 1 over 4 minus root h dh equals t to the power of 0.25 over 20 dt. Okay, so now from part A, we should remember that this is just equal to minus 8 ln 4 minus root h minus 2 root h, and then we can just equal that to this. And then we can rewrite this as t to the power of 0.25 over 20 integrated, like so. And if we integrate it, we get t to the power of 1.25 over 25 plus c. Obviously you can work this out, but I've just skipped that step. Okay, and then the question tells us that one of these trees is 1 metre high when it is first planted. So that's basically the first time, so when t is equal to 0. So we can say that when t equals 0, h equals 1. And then we can just plug these values back into the t and h of these equations. And you get minus 8 ln 4 minus root 1 minus 2 equals 0 to the power of 1.25 over 25 plus c. This will obviously become 0. And you get minus 8 ln 3, this 1 is just 4 minus 1, minus 2 equals c. And then to solve for t when h equals 12, well, this is our equation that we have, and then we've got our value for c, which is minus 8 ln 3 minus 2. So we can just put this back into this part of the equation, like so. And then when h equals 12, so we're going to put this value of 12 into the h. And then this part of the equation approximately equals minus 1.9378, which equals t to the power of 1.25 over 25 minus, and then 8 ln 3 minus 2 equals 10.7888. And then if we add 10.7888 on both sides, we get 8.851 equals t to the power of 1.25 over 25, multiply each side by 25. And you get t to the power of 1.25 equals 221.275. And then if you take the square root using 1.25 in your calculator for 221.275, you get t equals 75.2 years. And that is it. Thank you for watching, and I hope this has been helpful. Thank you.